Hi, everyone. My name is Ben Tudelo from the University of Calgary, and I'm one of the co-authors, along with Adedapo Aolayo from McMaster University, of the PyGeoChemCalc software, or PyGCC. And I wanted to take a minute today to record some tutorial instructions on how you might be able to use PyGeoChemCalc in your research. So I want to start by pointing you towards our documentation page, pygcc.readthedocs.io. And so on this page, there are lots of different tutorials and introductions into the PyGeoChemCalc software. So if you want to use PyGeoChemCalc, you're going to need a Python implementation. For example, a lot of us use Anaconda to run Python, but you can determine how you'd like to use Python in your own computer. So in order to install PyGeoChemCalc, we use this command, pip install PyGCC. So I'm just going to walk through how I would do that using Anaconda and the Spider interactive development environment. So here is Anaconda. When you install it on a Windows computer, you get this Anaconda Navigator software. If you simply click on the Spider software, this is the Scientific Python Development Environment, or Spider, you can launch it. And so I've already done that here. And I open here the Spider window. And so pip install PyGCC will allow you to install the PyGeoChemCalc software onto your computer. And this might take a minute depending on your internet connectivity. Because I already have it installed here on my computer, it does not need to be further installed. However, if I want to take or if I know that there are new updates to the software, then I will have to update the PyGeoChemCalc installation on my computer. And I can do that, and I will know that those updates exist on this Read the Docs page by going to this changelog page. And you see here are the recent additions. So these are from November 2022. And here is the command for upgrading or updating PyGCC. So it's pip install upgrade PyGCC. So I can copy it and paste that into my Spider window. And there you have it, pip install upgrade PyGCC. Again, the PyGCC on my computer is completely up to date, so this is not actually going to accomplish anything. So I can now clear that window and get into some examples on how to use PyGeoChemCalc. And so if you're looking for a tutorial guide on all of the various functions of PyGeoChemCalc, you can either go to the Read the Docs page here, so where we've listed various commands and their usage in Geochemist Workbench, or sorry, in PyGeoChemCalc and how to run those. And there's also more advanced examples here, for example, integrating PyGeoChemCalc with Geochemist Workbench or integrating PyGeoChemCalc with EQ36. Alternatively, and this is my preferred implementation, you can go to our Bitbucket page here, bitbucket.org/tulo-rtg/pygcc/source-master-docs, and you'll see there's a list of files up there that might be helpful for you. So these, example 1, 2, and 3 are all Jupyter notebooks, if that is your preferred style of using Python. Alternatively, you can go to these tutorial files here on this page and just download these to your computer from the Bitbucket. It might take a little bit of effort depending on whether you use Git or not. But anyways, they're here, so you can click on them, see the implementation, and you can either copy and paste this or then go to Open Raw and then right-click to download this to your computer by saying Save As, and then download it as a Python file. So either way that you'd like to get this, as long as you get the example onto your computer, then you can begin to run it. So I want to focus on this Generate Geochemist Workbench database example today because it uses a lot of the potential commands and functionalities of the software that might be of interest to you as a potential user. So if I minimize this window and go to my Spider window, you'll see here I've now opened that Generate GWB database.py example, and this is exactly as it was downloaded from the web page. So there's quite a few examples here. And so we can start by saying, I want to run a example where I can generate a Geochemist Workbench using the default source database with inclusion of solid solutions. So that's the plagioclase and olivine and pyroxene solid solutions, and the thermodynamic properties of clay from Blanc et al. 2015. So if I go and run this, so the first thing here is to import NumPy as NP, and then import the PyGeoChemCalc utilities in here, and then this sets the variables of the temperatures that I want. So these are the standard GeoChemist Workbench temperatures between 0.01 degrees and 300 degrees Celsius. You can change those as you'd like, depending on the conditions you're interested in. And then the pressure here is 350 degrees. And then in my Klein pyroxene solid solutions, I'm setting the number of calciums to 1. So again, I can go and run this. So if I only want to run the first example, I can then comment out all other examples in this way. And then I can press play at the top of the page here to run that first example. And so it says that it's running the file in my directory, and then it's doing the work. It generates a folder here called output, where it's going to put the output database that is at these conditions, temperatures and pressures, and Klein pyroxene calcium numbers as given above. So it is running, it's taking a bit of time because it has to run all the calculations for all those thermodynamic properties. But once it's done, it says success, your new database is ready for download. And then I can open this folder here, output, and then there's my Geochemist Workbench folder, because that's where I just generated a database for. And then here is that new database at 350 bars. So I can open that in Spider here and look at what that looks like. So you see that those temperatures and pressures are exactly consistent with what I had done before, or what I had input on the input file. And then if I want to go and use that database in the Geochemist Workbench, I can open the Geochemist Workbench. And for example, I can open the RxN module here. It's opening now. And then all I need to do is go to this folder where this database has been created, the output folder, and then just drag and drop that output database onto my my window there. And so now you can see there's all these new minerals that have been made. For example, plagioclase solid solutions up there with the anorthite numbers, betalite, various chemistries that come from the Blanc solid solutions, and so on. And then finally, here's those Klein pyroxene solid solutions, and here's the olivine solid solution. So all of those have been put into my database. And just to show that this database does work, I can, for example, balance a reaction for forsterite 50, phthalate 50 here, results, run, and there it is working. So that's an example of how to create a database in Geochemist Workbench. As you'll see in this introductory example file, there are many potential examples of ways in which you can use the Geochemist, or use PyGCC, PyGeoChemCalc, in order to create various thermodynamic databases for Geochemist Workbench. And so here's all of these different options down here. And I encourage you to explore them because you'll find that most of the potential applications that you'd like to use in PyGeoChemCalc or Geochemist Workbench have been included here. And at any point, if you are concerned that you don't quite understand something that PyGeoChemCalc is doing, or that if you find that you would like to do an option that you're not sure is included in this tutorial file, you can say help and then write database, in this case is the command that we're looking at. And then you get this nice help output file that says all of the inputs that are being put into the command, and then all of the potential outputs from that command. And so you see that there are many potential options that you might like to use. So thanks for listening, and I hope that this has helped you to understand how to use PyGeoChemCalc in order to achieve new thermodynamic data into your Geochemist Workbench implementation. Thank you very much.